everyone, my name is Ganesh and I'm a software engineer. In this session, I'll be talking about how to integrate LLMs and embedding models into Beam pipelines using Langchain. So the agenda for this session would be to I'll start with giving an overview about what Beam transform is and how Beam pipelines would be executed in general. And then I'll introduce Langchain-Beam library and its transforms, and then how to use the transforms in the pipeline, and um, in the session with a demo of the pipeline. Yeah, to start with, P-transform is basically a stage in the pipeline. It takes in the data and then applies the transformation logic on it, and then outputs the transform data. Um, there are multiple kinds of transforms, and you could create your own custom transforms. Uh, when the transform is applied on the input data, it basically outputs the uh, transform data's new set of P corrections. Um, Now we'll talk about how Beam pipeline uh, general works. Um, picture this. Picture it as a river flowing through a forest. It can go through multiple splits and turns, and there might it might even uh, split into a separate channel. Beam pipeline is just like that. The data source can be a waterfall. The waterfall is like a data source in a pipeline, and when the data reaches the P-transform, the transformation logic is applied on it, and then the new set of P collections elements is emitted, and then it reaches the next transform. Um, yeah, and there is bounded and uh, uh, bounded and unbounded P collections. Data sources, just like uh, stream can flow continuously. The data will uh, flow continuously in unbounded sources. So now I will introduce Langchain-Beam library. Um, Basically, it is an open source library that provides transforms for integrating models into the Beam pipeline. First transform is an LLM transform. Uh, the uh, the transform provides abstractions to integrate various models and models providers like OpenAI and Anthropic into the transform and leverage the model for processing the data. Typically, a transform would have a predefined processing logic. Uh, with this landing transform, it processes the data using LLM based on a pipeline author provided prompt. Uh, uh, so it takes an input P collection of elements, and then uh, the transform uses the model to process the data, and then outputs the Langchain output P collection, which wraps the model's output and then the input element that was processed. So now we got an introduction. I'll talk about how to utilize this transform in the pipeline. Um, yeah, let's have a scenario, right? Let's think I have a product and I have some user feedback of my product, and I would want to extract. Basically, I might have tons of user feedback, and I want to understand what users would think about my product. And first step would be to define the instruction prompt. Basically, to tell what to do, to tell the model what to do with my data in the pipeline. Second step, would be to define the model options. Model options are basically to define which model should I be. I'm planning to use, and then the AP keys for authentication and other optional parameters like temperature to control the randomness. Um, there are multiple model options classes present in the library. Let's say if you want to use Anthropic model provider, you could use Anthropic model options class. And third step would be to define the handler. The handler is just an object that holds the options and the prompt, and then now we could use the transform in the pipeline. This is basic syntax that tells like first step would be to read the input data, and then second step applies the LLM transform, and then third step can be anything. The transform data can be input to a different next transform, or you could I could write it to a data sync. Now that we know how to use the transform, and talk about uh, how the transform works internally. So just like any other transform, Langchain transform has layers to it as well. The top layer, which is public, uh, as a exposes a run method and takes an handler. Um, and internally, it calls an do fund to basically inference with the model using the Langchain Java. So now the do fund would do a few things to for us to give us the output. First step would be to initialize the setup, initialize the I mean, connect to the remote models API using the Langchain's chat language model, and it would perform chat language model is part of Langchain Java. It is a base class for uh, interacting with various model providers. It provides methods for calling the model, and then it handles all the inference logic. And we would utilize this chat language model object in the process element to call the model. So as a first thing, for every single input element, a final prompt would be constructed where the input data and then the formatted output format would be injected into the prompt, and the model would be invoked, and then the model's output would be wrapped into this Lang-Beam output and then emitted as a P correction. So this is the prompt template that I talked about in last slide. Uh, Basically, it provides context to the model, and during runtime, the placeholders would be replaced with the input element and the instruction prompt that pipeline author has provided, and the output format about the how the what's the model should respond it. Let's say let's go back to my previous example. I wanted to extract the sentiment and understand what my users would think about my product. Um, this is a very basic example, and uh, the model is going to respond in a plain text. But let's say, what if I had to like uh, categorize the positive reviews and negative reviews, and then uh, use the add attach metadata to negative reviews, and then maybe reach out to the users and then get their feedback. Um, um, uh, to address that, you could provide the output format to describe what's the structure that model should respond into. For in my example, I want JSON structure of review, the products review, and then the sentiment, which the sentiment of the review. So now when I read data from my locally and then apply the LLM transform, I would get the output in a JSON structure, and further I could uh, group by the negative or positive reviews for further downstream processing. Second transform is embedding transform. This is similar to the LLM transform, same APIs. But it basically integrates embedding models into the transform, and it takes an input P collection of elements and then uh, uh, generates vector embeddings for those elements and emits the uh, vector embeddings plus the input element. This is an example embeddings generation pipeline. Um, First step would be to define the model options, and here I'm using uh, OpenAI's model, and I'm going to use the same previous data. I mean, my product will use data and then generate vector embeddings for it using embedding transform. Um, and then I might write it to a vector database or perform similarity search later on. I would like to share a pipeline demo of the pipeline. This is my like sentiment generation pipeline. I've defined the prompt and then I have my keys for authentication and then I've defined the my options and output format, and I am loading the product reviews data and then applying the uh, LLM transform. So I'll run the pipeline. Here I'm basically extracting the model's output from the embeddings of the object, and the model has responded in expected JSON structure. And yeah, that's it.